cloning, clone. So clone means, what is it? Clone means a copy, exact copy, a duplicate. Yes. So here, let's see today how to create a clone. So in the last class, if you people remember, as I told you people, not all objects are eligible for cloning. Am I right? You know, not every object is eligible for cloning, right? So basically, which objects are eligible for cloning? Yes. Which objects are eligible for cloning? Yes. So the objects whose class implements clonable interface. The object whose class implements clonable interface. So those objects are eligible for cloning, right? That is what we have discussed. So clonable interface, it actually there are no methods defined in that interface. Basically, I can say that the clonable interface is a blank interface, and I told you people this type of interfaces you got a name for it. What is it? What do we call them as? Yes, the interface without any methods. We call them as tag interfaces or marker interface. The interface without any methods is called as a tag interface or a marker interface. So today we'll see how to clone the objects. So in order to clone the object, you will find that you got a method called as clone, and it is defined in object class itself. Okay, you got this clone method in the object class. Let's see. You see the clone method. Now there are a few things which you need to uh, observe. First thing is the clone method, it is declared as protected, right? Clone is protected method. Yes. Okay. Now, can I say that every class inherits this method? Can I say that each and every class in Java, it inherits this clone method? No? Why so? Okay. So what if the visibility is protected? If it is protected, what happens? I guess there is no such restriction if the method is protected. What is the issue if it is protected? The subclass which extends object class, don't you think it can inherit this protected method? Yes. Protected member of a class is always visible to the subclasses, no matter the subclass is in the same package or different package. It doesn't matter. Always the protected members of the class are visible to the subclass, right? Yeah. Just a second, please. Just a second. Yeah, I'm sorry. Yeah. If you want, you can just check that once. Earlier, definitely, I gave you that question, like what are the members of the superclass which can be inherited by the subclass. The subclass is in a different package. You see, you'll find that protected members are always visible. No matter the subclass is in the same package or a different package, you'll find that protected members will be always visible. Okay. Yes. So, of course, you see here, now this method will be inherited by the savings account class or product class. I'm sorry. Definitely, I can say that product class inherits this method. Which method? Clone method. But it is protected. Okay. So that inherited method is a protected method. That's the only issue. The subclass can of course can inherit this method. Okay. There won't be any issues. Fine. Now if you want the clone for this object, if you need a clone for this object, then in that case what you have to do here, you need to simply call the clone method. Okay, using that object reference called the clone method. If you need a clone, that is what you need to do. Okay, yes. So here, now the product class, where it is in com.java package. Okay, just check this. Now in the test class, we are trying to create this product object. Now I'll try to call that clone method, which is inherited by the product class. But you will find that here in this class, in the test class, you will not be able to call that protected method here. In the test class, you will not be able to call that protected method. Okay, this. So because test class is not a subclass here, okay, yes, that inherited method from the object class, you will find that which is particularly inherited by product class, it is only available for the product class. Now test class will inherit its own clone method. Okay, yes. Now all of you please try to understand this point. It is very important. That's the reason why I didn't discuss about it in the last class. So the clone method is protected. Now I can say that you got that protected method in the product class. Now what is the visibility of that protected method, inherited protected method here? Yes. What is the visibility of that inherited protected method? Yes. Now you have that clone method, right? Protected method. Let's say I'll just add it for your reference purpose. Let's say now I can say that yes, of course, you got that protected method here. Okay, clone method, which is inherited from the object class. Yes. Okay. Now that method is available in the product class. It's inherited method. Okay. Yeah. Just a second, please. Sorry. You see, this is a protected. Just imagine that this is the method which is inherited from the object class. Okay, I'll just comment it. Now, if it is protected method, now can you people tell me what will be the visibility of this inherited method which is protected? Yes. What will be the visibility of this method? Where it will be visible? Yes. Within the same package, is it visible to other classes? Within the same package, is it visible to other classes? What do you people think? Can I have yes or no? This inherited method, protected method,
Within the class, yes.
within the class, within the package.
Yeah, within the package.
Within the package also it will be visible. Protected method. It is in now product class is in which package? Yes. Product class is in which package? Product class is in which package? You want you can see this. com.java package. The product class is in com.java package.
Okay.
Okay. That means the protected method clone method which is inherited from the object class, it is visible within that com.java package now. Okay. Yes. Now outside of the package is that method which is inherited, protected method which is inherited by that product class. Outside of the package, is it visible to the other classes outside of the package?
No, outside of the package, no.
So it is not visible to the other classes outside of the package. Yes. So only to the subclasses it is visible. All of you got this point? Yes. Only to the subclasses it is visible outside of the package. Only visible to the subclasses. Please go through the statements I gave you people earlier. You can refer to them once. Okay. When we're talking about access modifiers, we have discussed about it. Yes. So only to the subclasses you see outside the package they are visible. So non-subclasses they are not visible. Yes. That means now the test class, will it be able to call that method, inherited method, clone method, the protected method, inherited method, will it be able to call it? No, because test is not a subclass now. It is not possible. Okay. Yes. So how do we make that protected method visible to the other classes outside of the package? Okay, how can we make this method visible to the non-subclasses outside of the package? What you can do here, do you have any solutions for this? I want to make that clone method visible to even non-subclasses outside of the package. So what are we supposed to do? Yes,
Import the class.
you know, we need to override that clone method. That's right, very good. Override the clone method And now you see, basically that clone method is protected in the superclass. You can make it public here. You can make it public. Subclass is inheriting it. Okay, right? But what we are doing, we are overriding this method. Here, we will not change that functionality. I don't want to change the functionality, override that functionality of the object class method. But instead, I want to change the accessibility or visibility of that method here. That's it. Okay. So, but I don't want to change the superclass method functionality. I want to use that superclass method functionality as is. So what we'll do here, we'll simply call that superclass method by calling this using the super.clone means you're calling the superclass method. Now what it does, it returns the clone of that object here. Yes, that's it. So what the main purpose of overriding this clone method from the object class is to make that method more visible. To make that method more visible, we are trying to override that method here. Okay, we're making it more visible by declaring it as public, I can say. Okay, yes, that is what we are doing. We got the point here. See, we are not changing the functionality. I'm calling that superclass method here so that we can make use of that superclass method as is without changing the functionality of the superclass method. We'll use it as is. That's it. Now we have changed the visibility of that clone method. Now I'll be able to use it. Okay, here in the subclass. Now it returns the clone for that product object. Okay, you'll get a product object clone. Yes, product clone. But you will find that always the clone method, it returns superclass object reference. We have to cast it. That is object class reference it returns. So we need to cast it accordingly. Yes. Okay, that's it. So this way we can call the clone method here. Yes, fine. Okay, you got the clone. Now in the clone also you'll have the exact data which you got in that original object. Okay, so product original, let's say the reference variable names I'm changing it for product original and product clone. Okay, so now let's read the data from that clone object. Okay, let's say id product clone dot get id name product clone dot get name price product clone dot get price description product clone dot get description. That's it. Okay. So now let me run this code. You see, you got the data which we had in the original object. Yes. Okay, fine. So I have a question for you people in this regard. Yes, try to answer this question. Product original dot equals of product clone. See, I'm trying to compare these two objects using equals method. So will it return true or false? So that equals method, which you're calling here, this statement, will it return true or false if I compare those two objects? Yes. You see, equals method, what it does, uh, did we override that equals method? I'm sorry. Yes, we did, right? So will it return true or false? Of course, it should return true because the contents of these two objects is same. Both the objects have got the same content, right? The clone object and the original one will have the same data. So don't you think it returns true? Yes. You got it, all of you? Hope so, right? The clone object and the original object will have the same data. Equals method will only compare the data contents in that objects. What if I use double equal to operator, the relational operator? Then what happens? This time, will it return true or false? So it should return false because you see the original object will be definitely different from the clone object. That means the memory which is allocated for the original object and the clone object will be different, of course. It won't be same. Okay? Yes. You got the point, all of you? Yes. The contents of the original object, okay, is same. I do agree, but you see, these two objects are different. The memory for these two objects is separately allocated. Okay, the memory for these two objects is separately allocated. Yes. Okay, that is what I want you people to understand here. Now I have a question for you people. Why do we need clone object here? Yes. Why do we need a clone object? Okay, something like a backup. Okay, yeah, basically, yes, the clone objects, they used as backup itself. For suppose, let's say you got a requirement where you need to modify the original object, or an object, manipulate an object. You're supposed to manipulate an object, let's say. Now you have the data or content in that object. You got some content or data in that object. Now, for suppose by mistake, if you did something wrong and you ended up manipulating that object wrongly, okay, yes, so that means you lose the original data, right? And you'll end up having some junk data in the object, which is not appropriate. Yes. So for suppose you see, if you got a clone and if you modify that clone object or even original object, still will have a backup. If you modify the original object, you got a clone object. You still got the data, yes, which you can simply use it. Okay. Yes. Okay. So you can retrieve the data from that clone. Yes. So this is how a clone object will be used. So whenever you're trying to update any object or manipulate any object, so if you can better create a clone so that you got a backup or copy of that object. If something goes wrong with that updates or manipulations, still you got that original data, okay, previous data, you got a backup, I can say. Yes, that's right. Okay, so is this clear for everyone? So anyone got any issues in this regard, please let me know. Yes, so this is about the clone. Yes, any doubts or issues in this regard? Okay, good. So hope you people got this concept. Now we got something called as deep cloning and shallow cloning. I want you people to go through this. This is a task assignment for you people. Check what is deep cloning and what is shallow cloning. Okay, this is your task. Deep cloning and shallow cloning. So it's pretty simple and straightforward. So definitely you'll understand. Okay. Yes. Yeah. So let's move on. Now these are the methods which you got in the object class, which I can discuss as of now, which we have discussed so far. Get class hash code equals clone to string. We are left over with notify, wait, and finalize. So which I'll be discussing about it later. At appropriate time, we'll discuss about it. Okay. So notify, wait methods are in thread programming. We'll talk about them in the thread programming, and finalize in the memory management. Yes. Okay. So let's start with this with the new topic here, right? That is regarding the memory management. Okay, memory management. Now from now on you'll find that regularly you'll come across those methods, object class methods. As I told you people, they represent the most common operations which we perform on the collections. Yes. Okay. On the objects, I'm sorry, not collections. Memory management. Yes. So when we talk about memory management, so here in the memory management, you will learn how the memory is allocated for the Java applications. Okay, what are the different types of memory used by the Java application? What are the different types of memory which is used by the Java application? And we'll talk about the memory allocation as well as deallocation. How the memory will be deallocated. Even that we'll discuss. Where we'll come across garbage collector and all. Okay. Yes. So these are all the things which you'll know. So you'll get an idea, a fair knowledge of how the memory allocations are done in Java for the Java applications. How the memory is allocated. Okay. Yeah. And what are the different types of memories used by the Java applications? Even you'll come to know about it. Okay. Yes. So memory management here, you'll find that you got different types of memory. Number one is heap memory, stack, or it is called as runtime stack, or it is also known as call stack. Next, we got string constant pool. Next, we got method area. So, as of now, we'll concentrate more on heap, stack, and method area. Method area also, there is nothing much to discuss, but heap and stack are important as of now. So later on, we'll see string constant pool. Okay. Yes. Okay, fine. So first of all, you see here, we'll talk about this heap memory. Have you people made a note of it? These are the different types of memory which you'll see in the Java applications. Okay. Now let's start with heap memory. Okay. Not just heap, even stack and all. So first of all, when we talk about heap memory, you know, this memory is allocated for the objects. The heap memory, usually you'll find that it is allocated for the objects. You know, in the object creation statement, if you people remember, always we used to instantiate the class, create the object using new keyword. As I told you, people, new instructs the JVM to create an object. At the same time, new keyword is also instructing the JVM to allocate the memory for the object. Okay, you can say that it is also asking the JVM to allocate the memory for the object. So whenever we ask the JVM to create an object, it allocates the memory for that object on the heap itself. It will allocate the memory for that object on the heap. So always the memory for the objects is allocated on the heap. So that means I can say that the Java objects, they live on heap memory. Okay, yes. Java objects basically they live on heap memory. Okay, is allocated for heap memory is allocated for Java objects. You can see. Yes. Next, what about stack memory? We are not yet done. Okay, completely. I'm just giving you people overview. Stack memory. Any idea stack memory is allocated for what?
Classes.
Okay, stack memory. Basically, it is allocated for the methods. Okay, so whenever by default, when we define the method, for that method it won't be allocated. But when you call the method, when you want the method to execute, you invoke it, right? So when you invoke the method, you see the instructions in the method will execute. So when that method, you know, is about to start execution, for that method, the stack memory is allocated. Okay, yes. Always for the method, you'll find that stack memory is allocated. Yes, got it. Now, stack memory is allocated for the method sequence. Okay, fine. Now, I will demonstrate this with an example. Okay, let's consider an example for this. Say this is the code which you got. Okay, so let's say these are the instructions which you got in the method, main method. Okay, now let me explain this how the memory is allocated for this method for this program. Now let's see. Okay, just a minute. So just assume that this is a heap memory. got stack memory on the other side. Yes. Okay. So now when you run this Java program, whenever we start the execution here, what happens? Always you know that the program starts execution from the main method. So immediately you see the memory, because the method is supposed to start with the execution. For that method, the memory is allocated on the stack. Okay. So for this main method, the memory will be allocated on the stack. That is what the first thing which happens. So when we run this application, so part of stack memory is allocated for the main method. Next, you know, you got a variable here, int I. There is a variable declared. This is integer type variable. Now where it is declared in the method, if we declare a method, sorry, yeah, if we declare a variable in the method, then it is what type of variable? If a variable is declared inside the method, then it is what type of variable? It is a local variable. Okay, it's integer type, I do agree, but all the variables which are declared inside the method, they call as local variables. Okay, so now where exactly the memory for this variable will be allocated? Where exactly the memory for this variable will be allocated? So what do you people think? Because it's a local variable, it is declared in the class, sorry, inside the method. The memory for this variable, you see, will be allocated on the stack itself. As part of the memory, stack memory, which is allocated for that main method, that part of that stack memory which is allocated for the main method will be used here. Okay, yes. That means now that variable I will be part of the stack memory which is allocated for the main method. Why? Because that variable I, where it is declared in the main method itself. So the memory which is allocated for the main method will be used for this variable as well. Yes. Okay, fine. Next, you see, always remember one thing: the local variables, you'll find that they live on the stack memory. Local variables, the memory for the local variables is allocated on the stack itself. It's okay. Now this account, it's also it's a reference variable, right? Now where exactly the memory for this reference variable will be allocated? Yes, where exactly the memory for this account variable will be allocated?
Stack.
On the stack. Okay. You see, you'll find that here this variable, because it's a local variable, I can say it's a local variable. Why it is a local variable? Because it is declared inside the method. It is declared in the main method. So it's a local variable. Here, the memory for this variable is allocated on the stack itself. So that to the part of the stack memory, so which is allocated for the main method, will be used for that purpose. This way, the memory is allocated for the variable accounts. Okay. Next, it's just a variable declaration. Next, we got new keyword, using which we are asking JVM to allocate the memory on the heap now, right? For that object, the memory will be allocated on the heap. Yes, we're asking the JVM to create an object. So always the memory for that object is allocated on the heap itself. So account number, balance, and bill. So this way, the memory for the object is allocated on the heap itself. But the reference to this object, it is stored in that local reference variable, I can say. It's a reference variable itself, but I can call it as a local reference variable because it is declared inside the method. It's a local variable itself, but it's a reference variable. So you see that account variable which is on the stack, reference variable which is on the stack, so it will be referring to the object which is on the heap here, I can say. Okay. So far what we did, is it clear for you people? Whatever I explained,
Yes.
can I assume that this is clear? Yes, hope everyone got it right. Yes, this till the statement, till line number 12. Okay, good. Now, we'll call this withdraw method here as part of this method. You see, you got instructions calling the withdraw method. Yes. Now, when this method is called, what exactly happens? So this is important to understand. First of all, I have a question in this regard. So when the withdraw method is invoked, okay, no doubt, the withdraw method instructions will execute. They will execute. But here, the thing is, what happens to the main method which is calling the withdraw method? That you need to understand. The thing is, you need to understand what happens to this calling method, the main method. So what it will be doing when the withdraw method is executing here? Yes. So will it wait, or will it simply render the response? What it does? Sorry. The main method, will it wait, or will it display this message? That means, will it render this message which you got here? That is end of main method. Yes. What do you people think? The statements, will they execute?
Yes. Wait.
So will it wait? Yes. It will definitely wait till, that withdraw method finishes execution and returns the response. So only after the withdraw method is done with the execution, you see, the control will be returned to this main method. Then the main method can execute the rest of the instructions which you got here in this method. Okay, only then the main method can execute the rest of the instructions, I can say. That's it. Till that time it has to wait. Yes. So in our case now, after calling the withdraw method, we see the method will start execution, right? Withdraw method, when it is invoked, yes, of course. So it will start execution. They see, for that withdraw method, you will find that the memory will be allocated exactly on top of this main method. The memory for the withdraw method will be allocated on top of the main method here. That's it. Okay. So you see, this is stack memory. Always the memory will be allocated this way itself. Now you see, the stack, why it is called as call stack. As I told you people, the stack is also called as a call stack because it will have that method call details. Someone, if they read this call stack, they will be easily able to understand the method invocations, how they have been invoked. You see, whichever element is at the bottom of the stack, that is the first method to start execution here. That is the first method to start with the execution, main method. You see, main method is calling withdraw method, so that's the reason why your withdraw method is on top of main method. And what if withdraw method is calling some other method, XYZ method? What if the withdraw method, if it is calling some other method here, then what happens? Just assume, let's say withdraw method is calling some method here called as X. Now the control from withdraw method will be transferred to that method X, and the memory for that method X will be allocated on the stack. Part of stack memory will be allocated for that X method. X method which is invoked by withdraw method. Okay, yes. So now, which method is a currently executing method here? What do people think? Which method I can say that it is a currently executing method? Yes. You see, whichever method is on top of the stack, whichever method is on the top of the stack, I can say that that is a currently executing method. So X method, which is on top of the stack, I can say that this is the currently executing method here. Yes. And which method is calling that X method? Which method is calling the X method? Withdraw method. And which method is calling withdraw method? The main method.
Main method.
Yeah, main method. Withdraw method is invoked by main method. I'm sorry. So now this is how you see you'll have this method executions, method calls, and all. Now once the X method, if it finishes execution, then what happens? Once the X method finishes execution, the memory which is allocated for that X method will be deallocated. The memory which is allocated for the X method will be deallocated. And one more thing happens here. What is it? The control will be it will be written back to the calling method, which is withdraw method in this case. Okay. Yes. Okay. Once you see, now withdraw method will get the control, and withdraw method will start execution. And once the withdraw method finishes execution, then what happens again? The control will be handed over to the main method here. And you see the memory which is allocated for that withdraw method is also deallocated. Yes. Okay. And once the main method finishes execution, the memory which is allocated for the main method is also deallocated. That's it. That is how it works. That means the memory which is allocated on the stack, you see, we don't need to manage it. So whenever the method starts execution, the memory is allocated for that method on the stack. And once the method finishes execution, again immediately the memory is deallocated. The memory is allocated and deallocated accordingly. So now we don't need to worry about that stack memory. Okay, so it is automatically managed, I can say. There is nothing which we can manage here. Okay, memory is allocated and deallocated automatically, you know that. So when the method starts execution, the memory is allocated on this time. And once the method finishes execution, the memory is deallocated for that method here. Yes. Next, what about the heap? So when it comes to heap, you see, we explicitly place a request, you know, to allocate the memory on the heap, right? So how do we ask the JVM to allocate the memory on the heap? Yes. How do we ask the JVM to allocate the memory on the heap? Yes. We use new keyword. New. Why it is used? New. Yes. Fine. Let's say once the memory is allocated, let's say for that object, okay, let's say we'll use it. And once I'm done using that object, okay, that newly created object, I'm done with it. So now I would like to ask the JVM to deallocate the memory. I would like to ask the JVM to deallocate the memory which is allocated for that object. The way we are asking the JVM to allocate the memory using new keyword. So is there any such special keyword to request the JVM to deallocate the memory? Yes. Are you people familiar with it? Is there any such keyword which we use to request the JVM to deallocate memory? That means destroying objects. So actually, there is no such variable or keyword which we can use to request the JVM to deallocate the memory which is allocated for the object. You know, Java won't allow us to do that. Okay? Directly we cannot ask JVM to deallocate memory. In fact, there is no such option or keyword which we can use to ask the JVM to deallocate the memory here. Okay? Yes. Just a second. Okay, sorry. So that means in Java we are only responsible for requesting the JVM to create objects. Okay, we can write the code to create objects, but we cannot ask JVM to destroy that objects or deallocate the memory which is allocated for that objects. Okay, so but when exactly the memory for this object will be deallocated? You see, there should be some sort of mechanism, right? So when exactly this object will be destroyed, or in other words, when exactly the memory for this object will be deallocated? What do you people think? Yes. Okay, good. So don't worry, even if you don't know the answer. So you'll find that here, whenever that object becomes unreachable, whenever that object becomes unreachable, then you'll find that that object will be destroyed, or the memory which is allocated for that object is deallocated. The memory which is allocated for that object is deallocated. Okay, the objects which are not reachable or unreachable objects, I can say unreachable objects. Okay, unreachable objects. Unreachable objects. Unreachable object means, or I can say, yeah, unreachable object means the object which is not accessible. Okay, object which is not accessible, which you cannot access it. So for example here, let's say if I do this account equal to null, so in line number 16, what we are doing is that reference variable we are assigning null. So what happens if we do this? You see, earlier that reference variable account, it was referring to this object. You see account, it was referring to this object. Okay, sorry. Now the question is here, when I assign null, that means that reference variable, it is not referring to that object anymore. That reference variable account, it is not referring to that object anymore. Okay, that means, can we access that object? Is it possible to access that object? No. No, we have, we have reassigned that object reference with null reference. That means null means nothing. The account reference variable is not referring to any object. Earlier, that account reference variable, you see, which you got, it has got a reference. It was referring to that object, but now it is not referring to that object anymore. Okay. Now this object, I can say that basically it is not reachable. This object is not reachable. We cannot access that object. You'll find that here, always here Java will try to identify such objects which are not reachable. And it will reclaim the memory which is allocated for the objects here. What it does, it will reclaim the memory which is allocated for that object. The object will be destroyed, simply I can say. So, any questions in this regard? Now, some people might be expecting a few more details about this reclaiming the memory. You know what Java does here? Java on its own, it won't reclaim the memory which is allocated for that objects. So here, you know, the garbage collector, it plays a key role here. So garbage collector is a background thread, I can say, which always executes in the background. So garbage collector is mainly responsible for reclaiming the memory which is allocated for unreachable objects. The objects which are not reachable, unreachable objects. So I have a question for you people now. How exactly this garbage collector works? You know, the garbage collector, will it reclaim the memory of an object as soon as it becomes unreachable? The garbage collector, will it reclaim the memory of an object as soon as the object becomes unreachable? Yes, the garbage collector, will it immediately reclaim the memory of an object as soon as it becomes eligible for garbage collection?
Yes.
I can say no. As soon as the object becomes eligible for garbage collection, it is not destroyed. You'll find that it will wait for the JVM to call the garbage collector. You know,
Okay.
at regular intervals, it will be invoked, or sometimes when the JVM finds that there is a memory crunch, shortage of memory, JVM will call the garbage collector so that it can clean up that memory. So garbage collector, it will be invoked, you know, by the JVM. So whenever it feels like there is shortage of memory, it will wait for the JVM to instruct it to clean up the heap memory. Always the garbage collector, it only acts on heap memory, and garbage collector is it's responsible for cleaning up the memory, heap memory. Okay. Yes. So on its own, it won't clean up the memory. It has to be invoked by the JVM. Okay. Then only the garbage collector will clean that heap memory. Will check whether there are any unreachable objects, the objects which are not useful, which are not used, it will destroy them. Yes. Okay. So as I told you people, JVM itself is calling the garbage collector internally. But let's say what if I want to clean up the memory? Can I call that garbage collector? Is there any option to call the garbage collector? I can say yes. Yes, we got an option. Okay. You'll find that we can call the garbage collector using this GC method. That's it. Call the GC method. Okay. Okay, fine. Hope you people got it. Now GC method, when you call it, what happens? So by calling the GC method, I can say that we are requesting the JVM to call the garbage collector. By calling the GC method here, we are requesting the JVM to call the garbage collector. You know, using this GC method, we cannot directly call the garbage collector. We are just asking the JVM to call the garbage collector. 99.9% the JVM will oblige your request. It will take your request. Of course, it will call the garbage collector. But in some cases, it may not do that. Okay. For suppose, if the JVM feels like executing the garbage collector may slow down the performance of the application. Executing the garbage collector, if it slow downs the performance of the application, in that case, it may not call the garbage collector. Sorry, yeah. In that case, it will not call the garbage collector. And second thing, if the JVM has recently invoked the garbage collector, in that case also, it may not take your request to call the garbage collector. Yes. Yes. So hope you people got it. So in two cases, one is if the JVM has recently called the garbage collector, it may not call the garbage collector. Or you see, calling the GC method if it affects the performance of the application, in that case it may not call it. It is recommended you don't call the GC method frequently. Okay. Yes. Fine. So the GC method is also defined in another class called as runtime. We got another class called as runtime. In that class, you got this GC method as well. But I'll talk about it in the next session. Okay. So I'll stop it here little early. So today, what we discussed about the memory management, especially like you see, we saw that we got different types of memory like heap, stack, string constant, pool, and the method area. So about method area, I'll talk about it. Okay, don't worry. So you see this, you'll find that the heap memory is used for the objects, right? The heap memory basically it is used for objects. And what about stack memory? It is used for methods. Okay, yes. And what else we have discussed? You see, we have gone through how the memory is allocated for the methods, for the variables, and all such things. And then we have discussed about the garbage collector, which is used to reclaim the memory which is allocated for unused objects or unreachable objects. Okay,
Yes.
so now garbage collector, as soon as the object becomes eligible for garbage collection or eligible for, or as soon as the object becomes unreachable, the garbage collector will not destroy that object. An object, as soon as it becomes unreachable, the garbage collector will not destroy that object. Then when it does that, only when the JVM calls it, or we can explicitly call it. Yes. So these are the things which we saw today. So in the next class, I'll talk about that runtime class, GC method in the runtime class, and I'll demonstrate. Definitely, we'll see whether JVM is cleaning up the heap memory or not. Okay, and then finalized method of the object class. So we should be able to complete this, and in the next class, definitely I'll start with exception handling also. Okay,
Mm.
exception handling. So that is what we'll be doing in the next class. Okay, so I'll stop it here today. Let's meet tomorrow.